This video continues the exploration of features of graphs. And in this video, we'll focus on how do you tell when a function is positive, negative, or zero. So here are our definitions. A function is positive when the graph is above the x-axis. So positive means that the graph is above the x-axis. This is because the y values are positive when you're above the x-axis. A function is negative when the graph is below the x-axis. That would be the negative y values. And a function is equal to 0 when the graph touches or crosses the x-axis. Let's look at this graph of y equals g of x. And we have a curve that starts out below the x-axis, comes up through the x-axis to a high point, turns back around, goes back through the x-axis down to a low point, and then comes back up and touches the x-axis. So we're going to answer a few questions about this graph. First of all, is g of -1 positive? So remember from our function notation that the number being plugged into a function is an x value. So this is an x value of -1. To find g of -1, we want the y value. So we look at when x equals -1, what does y equal? So we go to -1 on the x-axis, go to your graph, and we have that point right there, -1 for x, +3 for y. So when x is -1, y equals 3. So that tells us that g of -1 is equal to 3. So yes, g of -1 is positive. Now we're asked for which values of x is g of x equal to 0. So g of x equals to 0 means on the x-axis, or the graph is crossing or touching the x-axis. So crossing or touching the x-axis. In other words, the x-intercepts. So I'm going to look at this point, x equals -2, x equals 1, and x equals 4. Those are the 3 points where the graph is crossing or touching the x-axis. So x equals -2, 1, 4. Those are the places where my graph is on the x-axis. And notice it said which values of x. So I'm answering in x values there. Now they say, for which values of x is g of x less than 0? So let me get another color here so I can kind of trace it on the graph. G of x less than 0 means that the graph is below the x-axis. So I'm going to scroll down just a little more. I can still see the graph. So I'm looking at the points. So here's where the graph is below the x-axis. I have this part right here. And notice that's a filled in dot, so it's included. And then I have this part right here. So I look at the x values there. From x equals -3 to x equals -2, my graph is below the x-axis. So it says write it using interval notation. I'll use a bracket because I have a solid dot or filled in dot. And a solid dot always uses a bracket because it's included. That point is included. So I will have from x equals -3 to x equals -2. Now at x equals -2, g of x equals 0. So I don't want to include the -2. I'll use a parenthesis because this is strictly less than. You may have a problem where it says less than or equal to, and you would include where it crosses the x-axis. But in this case, it's strictly less than, so it's strictly below the x-axis. Now you can use the union symbol, or you may be asked to use a comma to separate your intervals. And we'll look at the next interval. So from 1 to 4, from x equals 1 to x equals 4, remember our intervals are using those x values from 1 to 4. And at x equals 1, my graph is equal to 0, so I don't want to include it, so I'll use parentheses. Same with at x equals 4, my graph is actually equal to 0, so I won't include the 4 either. So this is the interval notation for when my graph is strictly below the x-axis. Now, again, we've talked about interval notation a few times now, but with interval notation, these are all x values. So all 4 of these values are x values. So these are x intervals. They give a left bound and a right bound for where your graph is below the axis. Let's look at one more example. We have a different graph here, and we want to use the graph of the function y equals h of x to answer our questions. Actually, it's the same graph, and we're just on part D. Okay, so we're on the same graph. No, it is a different graph. Okay, so we have a different graph. And part D says, for which values of h of x is, so for which values of x is h of x greater than or equal to 0? All right, so we're looking now, h of x is greater than or equal to 0. This means that I want the graph to be above the x-axis or touching the x-axis. Because of that or equals to, because of that bar right there. So I look at where my graph is above the x-axis. And I want to look at the x values. So 5 is the largest x value. And then my graph is touching the x-axis at x equals -3. And so I'm going to include the -3 because of that or equals to. And then go to 5, and I'll include the 5 also because my graph is still above the x-axis and I have a solid dot. So this would be the interval of x values. These are both x values. It's a left x value to a right x value, and that would be the interval notation. Okay, so keep in mind, equals to 0, a function equals to 0 means where is your graph crossing the x-axis? A function being less than 0 means where is your function below the x-axis? And a function being greater than 0 means where is your function above the x-axis? But we're looking at it in terms of x intervals. So you always want to have a left bound and right bound of where that's occurring. The y values don't play a role in our answer, except for showing us where it's above the axis and where it's below the axis.